In this video, we want to introduce the fundamental theorem of calculus. So that sounds like an important theorem, and it really is. It's the one that connects the derivative with the integral. So in some sense, we've already seen this theorem before, at least at the level of Riemann sums. We wanted to figure out the total change. And the basic formula is total change is equal to the rate of change times the length of the time interval, that is, so times the time interval length. So if it's 5 hours, we put 5 hours, and then a rate of change, and that gives us the total change. And then we could do this over individual subintervals, and that led to the idea of Riemann sums. And when we take the limit, we actually get not just an estimate, but we get the exact value. And that's going to be in the form of integral of a to b. The rate is now the derivative of a function f of t dt. So it's important to note that f of t, f prime of t is the rate of change. So if we take the integral of the rate of change, the total change, that's represented here, well, the total change is also represented by what happens at one endpoint. This is what's true at one endpoint minus what happened at the first endpoint. So if we started with a value of f of a and we ended up with a value of f of b, then this is the total change that happened. And that's the integral of f prime of t dt. And this is the fundamental theorem of calculus. Just this formula itself, something that if you understand what we've been discussing until now, this will seem obvious. This is the fundamental theorem of calculus. Where it's important to note, this is the derivative of f, and this is not the derivative. This is just the value of the function. Okay, so again, both sides of this equation represent total change. This one is obtained by taking a limit of Riemann sums. This is just checked by seeing what the values of the function capital F are at the endpoints. The use of this comes in trying to either figure out the left-hand side or figure out one of these, f of b or f of a, given one of the others plus information about the definite integral. So for example, if you want to know f of b, you can rewrite this formula as f of b is equal to f of a. I bring the f of a to the other side, plus the integral from a to b of f prime of t dt. So that's one variation on this theme, which tells you if you know f of a and you know the definite integral, then you can figure out what f of b is. Okay, this is a short introduction to the fundamental theorem of calculus.